folks, it's Miss Mulling. I'm sure you guys recognize the two pictures in the corner. These are both pictures of James Bond. And I thought it was kind of fitting since we're going to start bonds right now. But we're not talking James Bond, we're talking chemical bonds. Okay, so your instructions for today. I'd like you to take notes on what you see here on 28 IP in your science notebook. And to make sure you have everything, I would like you to cover in your notes why atoms bond, what are ionic bonds, and what are covalent bonds. And just remember, feel free to pause and rewind as many times as you need to get all this information down. Okay, there's no hurry. Alrighty, so a little bit of review. We know the atom is the smallest unit of matter, and it's considered indivisible. So it's the most basic you can get. And then remember that electrons are filled in a certain order. So in this very first electron shell, you have 2 electrons. If there was another shell out here, you would be able to have 8, and if there was a third shell, you'd be able to have 8 in that as well. Since this is a helium atom, it only has 2 electrons, so we don't need to go into those other shells. Okay, so you guys recognize this. This is called the periodic table of the elements. And what we're going to do for today is pretty much ignore this green section, this red section, and this kind of browny gold section. We're just ignoring those. So on the next slide, you'll see that we smashed together these 2 groups and these groups over here to make it a little bit easier to see. And what you'll notice is that all elements in the first group have 1 outer electron. So hydrogen has 1 on this shell, lithium has 1 on this shell, sodium has 1 on this shell. And then next, you'll notice they all have 2. So beryllium has 2 on the outside, magnesium 2 on the outside. And then you'll notice 3, 4, 5, 6, 7, and 8. And you'll notice there's a red box around these ones with 8. They are said to have a full valence. So helium again has 2 because that's the only electron shell it has. After that though, every other one has a shell that holds 8 electrons, and every one of them has 8 electrons in that outer shell. We consider these guys happy. They don't really want to do any changing. They're happy as they are. Okay, so moving on. I believe on 28 OP, sorry, you guys were working on drawing Lewis dot diagrams. So you'll notice, just like we saw in the periodic table on this page, all the elements in the first group have 1 outer electron. Second group they have 2, third group they have 3, etc. All the way over here until we get to our noble gases, where every valence electron is there. They're full, they're happy, they don't want to do any changing. Okay, so part of your notes was to write down what a chemical bond is. And a chemical bond is simply an attempt to fill every electron shell. Okay, atoms want to be happy. If they don't have a full valence, they want to try to fix it, and they do that by this chemical bonding. We're going to talk about 2 types. The first is ionic bonds, and the second is covalent. I don't want to give you any details right yet, just because it's a little complex, so we'll move on and you'll get your details in just a minute. Okay, ionic bond, starting with the first one. This is a bond formed between 2 ions by transferring electrons. One will give up an electron, one will take an electron. You have transferred them. You're not sharing. One gave, one take. One gave, one took. Okay, so here we go. Ionic bonds are between atoms of metals and nonmetals. Again, they're formed by transferring electrons, not sharing. And in the end, you end up producing a charged ion. So we studied ions earlier. That's if you gain or lose electrons. Okay, when you're transferring electrons, you're either gaining or losing them. So you end up having ions. Some examples: sodium chloride, calcium chloride, potassium oxide. These are all salts. This is actually what you put on your food to make it taste better. And they're all done by ionic bonding. Okay, so just to review how we get a sodium ion. Sodium, if you look at a periodic table, is in the first group, so it has 1 valence electron. And if you look at all of its electrons total, which it should have 11. There's 2 in the first shell, 8 in the second shell, 1 in the third shell. Remember, every atom wants to be a full valence, and so this one only has 1 electron in the outer one. It kind of thinks, hey, if I get rid of this 1, then I'm left with 8 in my valence, I'm happy. So it tries to get rid of an electron. When that happens, now you only have 10 electrons, but 11 protons still. So you end up with a positive 1 charge. And again, now you have that 8 electrons in your valence. So sodium is now happy as an ion. To go the other way, we'll look at fluorine. So fluorine, if you look, has 7 valence electrons. In its head, it's just thinking, okay, I need that 1 more to get to 8, and I'll be happy. So what it does is it tries to find an electron just floating around, and it will grab it. When you have 10 electrons and only 9 protons, you end up with a negative 1 charge. So we would now draw our Lewis dot structure like this. Okay, so again, fluorine is happy, but now it has a negative charge. And if you look back at this slide, sodium is happy, but now it has a plus charge. We know that opposites attract. And you can think of ionic bonds kind of as this big greedy dog. If there's a little dog over here with a bone and a big dog over here, it's going to want the bone. It will simply take it and keep it. Okay, there's no sharing. It'll just simply take it and hold on to it. Okay, so what does this actually look like? On the left over here we have sodium. Again, it has 1 electron in the outer shell. It's not happy, so it tries to get rid of it. Chlorine this time, if you look, there's 1, 2, 3, 4, 5, 6, 7. It thinks, oh, if I could just get 1 more, I would be happy. They're in luck. Sodium wants to get rid of 1. Chlorine wants to gain 1. So they do. Okay, see this pink one over here? Chlorine now has 8. Sodium now has 8. But that leaves it with sodium as a plus charge, which we call a cation, and chlorine with a negative charge, which you call an anion. And now they're going to attract, right? Opposite charges attract, and that's actually what results in that bond. Okay, so an electron from sodium is transferred to chlorine. This causes a charge imbalance. Sodium is positive, chlorine is negative, and opposite charges attract, making that bond and keeping those 2 atoms together. Okay, moving on to covalent bonds. So we've already talked about ionic, where 1 gives an electron and 1 takes an electron. In covalent bonds, the bond is formed by sharing electrons. Okay, so it's not giving, it's not taking, they're sharing pretty equally. Usually these occur between non-metallic elements, so anything that's a nonmetal with a nonmetal. And again, formed by sharing electrons. Some examples, oxygen, carbon dioxide, and water. So if we look here at these 2 oxygen atoms, if you count how many valence electrons an oxygen atom has, it has a 1, 2, 3, 4, 5, 6, and then same over here, 1, 2, 3, 4, 5, 6. If this oxygen were to just give up 2 electrons to make this one happy, this would have 8 valence electrons. This one, though, would only have 4, so it's still not happy. The only way for both of these to be happy at the same time is to share these ones that I've circled in red. So if you look at this oxygen atom on the left, it essentially has 1, 2, 3, 4, 5, 6, 7, 8. This one on the right essentially has 1, 2, 3, 4, 5, 6, 7, 8. So these 4 right here that I've circled in red are shared between the 2 atoms. They kind of rotate together. Okay, this one doesn't keep them more, this one doesn't keep them more. They're both shared equally. Okay, when you have these 2 put together, we call it an oxygen molecule. But again, it's bonded together just by sharing those electrons, and we call this kind of bond a covalent bond. Okay, that wraps up our bonds. Here's 2 more just to leave you with a picture, and I hope that helps.